All right, so let's see. In this problem, this is one of those that they're not just coming right out and telling me the alpha, but they're giving me enough information to get the alpha. So I have to do a rotational kinematics problem to get the alpha. The thing is, they want the torque, and we know that the formula for torque equals I alpha. So I'm assuming it looks like I'm going to be able to get the I from the mass and the radius. So I'll be able to get the I from that, and I'll be able to get the alpha from all this other stuff. So let's do that first. Let's get the alpha. So I know I'm going to need alpha, and I want that to be in radians per second squared. So it says the circular blade on a radial arm starts turning at 3,200 revs per minute at the instant the motor is turned off. In 16 seconds, the blade is reduced to 720 revs per minute. So both of those have to be converted. And I think if I thought ahead of time, I would have. Well, I haven't made copies of the test, so maybe I'll change those to radians per second so you don't have to convert, if I remember, because I'm gonna have to convert here. So omega O is 3,200 revs per minute, and omega F is 720 revs per minute. So in both of these, it's going to take me, I'm going to have to convert the rev to radian. I'm going to have to convert the minute to second. So I've got a couple conversions to do in both of these. So I'm going to go from revs to radians, and I'm going to go from minutes to seconds. So same thing here, radian, rev, minute, seconds. So 1 rev is 2 pi radians, 1 minute is 60 seconds. So I'll do it up here. 2 pi radian is 1 rev, 1 minute is 60 seconds. So what do you get for those two answers for my omega O and my omega? What's my omega O? 335. And what's my omega F? What's the omega F? It's going to be smaller, right? 75.4, and I'm going to actually just write it as 75. 75.4? I'm just going to write it as 75 because if I've already written the number 335 to the nearest radian per second, the nearest whole number, then I'm going to just keep it so it's consistent. Like, why would I have one number to the nearest 1 and the other one to the nearest tenth of a radian per second? So I have that, and then this is all happening in 16 seconds. So those are your facts. Step number 2 is to pick the correct equation, which is omega final equals omega original plus alpha t. Step 3 is to solve for alpha. So alpha is going to be omega final minus omega original divided by the time. And then we just plug in the numbers. So step 4, alpha equals omega final minus omega original divided by time. So I'm going to put in 75 radians per second there. I'm going to put in 335 there. And I'm going to put in 16 seconds. So I know my answer is going to come out to be negative. So it's going to be a negative, meaning it's slowing down, not meaning that it's going clockwise. So sometimes the negative means counterclockwise or clockwise, and sometimes the sign means clockwise or counterclockwise, and sometimes it means slowing down or speeding up. This one, it means slowing down. So what is the answer for that? Negative what? Negative what? Negative 16.2 radians per second squared. So now that we know that, we need to get the I, and then we'll have both numbers to get the torque. So this is a circular blade. So what shape do you think that is? Circular blade. What? a cylinder because it's like a disc and a disc is a cylinder. So we're going to use, I'm doing it in a different color here. We're going to use I equals 1/2 mr squared. And then just plug in the numbers for that. I know I'm running out of time, so I'll just explain it. So just plug in, they gave us the mass and the radius, plug in there. And then that'll get us the I. And then you're going to take the answer for this and multiply it by that. And that'll get you the torque. All right? I don't need to do that. You know what to do next, right? Okay, so, oops.